Welcome to this week's multiple choice, Monday number 9. So the correct answer to this calculation was B, 186 decimeters cubed. Let's work out how we got there by working through the calculation step by step. So the first thing we need to do is use the fact that we've been given the mass of butane to work out the number of moles. So the formula of butane is C4H10, and that means my MR is 12 times 4 plus 10, which gives me an MR of 58. And so my moles is going to be 14.5 divided by 58, which gives me 0.25 moles of C4H10. Then I'm going to use the balanced equation to work out the moles of oxygen. Be careful, because the balanced equation, there are 2 moles of butane to 13 moles of oxygen. That means that my ratio is 1 to 6.5. So for every 0.25 moles of butane, I'm going to need to multiply that by 6.5, meaning that I will need 1.625 moles of oxygen gas. We're then going to use our standard molar volume of a gas, and that is because the question is telling us that it's being carried out at room temperature and pressure. To room temperature and pressure, 1 mole of gas is equal to 24 decimeter cubed. So my volume of O2 is going to be the number of moles that I've got, 1.625, multiplied by the molar volume, which is 24. That gives me a volume of oxygen of 39 decimeters cubed. And if you're not careful and didn't read the question properly, that is exactly where you might stop and choose your answer as A. But this question says what volume of air is required to burn this much butane, not the volume of oxygen. So, important thing that we should know, sort of both from GCSE and from our general knowledge, also at A level, is that air is made up of 21% oxygen. So it's not pure oxygen. Stands to reason, therefore, that I will need a larger volume of air in order to get my 39 decimeter cubed of oxygen. So thinking about how I would calculate the volume of oxygen if I knew the volume of air, I feel like this is the easiest way to reverse a percentage calculation. Is if I wanted to know the volume of oxygen, I know that the volume of oxygen is 21%, which can be written as 0.21 multiplied by the volume of air. By writing it out like this, can you see that in order to find the volume of air, it's going to be equal to the volume of oxygen divided by 0.21. That's the same as multiplying by 100 and dividing by 21, which is basically reversing the percentage equation. So the volume of oxygen is 39. If you divide 39 by 0.21, then to 3 significant figures, you get an answer of 186 decimeter cubed. It's actually 185 point something, but it rounds up to 186. Want to know more? Maybe brush up on your equation skills? Then check out my free online course, which really goes over some of the basics of different types of equation, including ionic and half equations. And there are more practice exam style questions, especially calculation questions. All of them include videos going over the answers on my website. And of course, follow me on Instagram and Facebook for more A-level chemistry tips and revision materials.